Alright, so for factoring practice, we're going to go through and do some problems together from the assignment. So the very first thing we're going to talk about is how quadratic equations can be solved by factoring, and we're going to use the problems below to refresh our factoring skills. So the most important factoring skill is factoring out the what we call the greatest common factor, also known as the GCF. So I'm looking at number 2. I'm going to be jumping around because I'm going to be picking questions that I want to address with you and then having you try some on your own as well. So we're looking at 4x to the 8th y plus 64 x to the 4th y. So greatest common factor is the biggest number and or variable to what power you can divide each equation by. Okay, so what can I divide both these equations by? What number?
2.
8. Yes, 8 is bigger than 2, so we want 8, right? Good. So while 2 is a factor, it's not the greatest common factor, right? So that is the number portion of your greatest common factor. Now we also have a variable portion. So what you do for the variable portion is both of these have an x. So what is the lowest x power we have in one of our terms? 4. So you always divide by the lower one because that one both of them will contain. And then what about y?
Just y.
Just y for both of them, yeah. And remember, whatever you choose as your greatest common factor has to be the same for both. So whatever you factor out or divide by, you're going to write on the outside of your parentheses when you factor. So it's going to go right here on the outside. And then I'm going to divide each of those terms. So 40 divided by 8 is 5. What is x to the 8th divided by x to the 4th?
4.
X to the 4th. So what you do when you're dividing common bases with different exponents is you subtract. So division, you subtract the exponents. If you're multiplying, you add them. And then what happens to the y's? Good, they cancel out. And then over here we have 8. And what happens to my x's as well here? Yeah, they also cancel out. And the y's cancel as well. So I left myself a little too much room here. But yeah, that would be your answer. So this would be your final answer right here. That's fully factored. Fully factored. Is it coming back a little bit now that you've seen it? Okay. Alright.
Oh, okay, never mind, I got it.
You got it? Alright, you guys want to look at number 4? You want to do another GCF one?
Can we do number 1? Because number 1 was kind of confusing.
Sure, we'll do number 1. Alright, I guess we're looking at number 1. Okay. So for number 1, what is the GCF of those two terms?
6.
Good. So all it is 6 2k minus 3. And that'd be your answer on that one.
You wouldn't divide by k as well?
You wouldn't divide by k because both terms have to have the k in them for them to be part of the GCF. Alright, so let's look at a little bit of a harder one for the GCF. Let's look at number 4. Because I want to do number 4 with you and not leave you just figuring it out on your own. So that's 3ab squared minus 5a squared b plus 8ab. So do I have any numerical GCF here? No, but I have a variable one, right? What is it? Good. That's it, a and b. And they're both to the first power because that is the lowest term of basically the term that has the lowest a and b. So when I divide everything by ab, that means I'm factoring ab out. And this is going to become 3b because I subtract exponents. And remember, when there is no exponent, it's just 1. So 2 minus 1 is 1. Okay, and the a's cancel out here. Now over here it's going to be negative a, or negative 5, and over here I'm going to subtract these, which gives me just a to the first. My b's cancel out, plus, and then here the a and the b cancel, plus 8. And that would be your final answer for 4. And you can always check your work by distributing back out. So like you could distribute this AB back out and make sure you get what you originally had. Does that make sense? Okay. That's how you can check your work. So you see that blank on your notes? It says when factoring, always look for its GCF, greatest common factor. So that's like the main important thing we want to teach you with this lesson. Before you use any other factoring method, you need to make sure you factor it out the GCF first if there is one. There won't always be one, but if there is, you need to factor that out first. Alright, let's move on to trinomials. So factoring trinomials is a little bit different. Let's just start with number 5. So it's probably been a little while since you guys have done one of these, so I'll talk you through all the steps. So we identify this as a trinomial because it has 3 terms, and we call this, it's basically a quadratic trinomial because it's in the form ax squared plus bx plus c. So if you have a trinomial in this form, you can use this method. Now, in order to use this first method we're going to look at, your a has to be 1. So in this case, is my a 1? Yes, because I don't have a number in front of my x squared, which means it's an implied 1. So in order to use this method, you need to confirm that. We did. Now we can move on to the next step. So what you're going to do with this method is you're going to look at your c term, your number, the one that doesn't have a variable. Okay? And what you're going to do from here is you're going to write that number off to the side somewhere, and you're going to take whatever sign it has. So if it's positive, it's going to be positive. If it's negative, it's going to be negative. Okay? And what you're going to do is you're going to look for all the possible factors of that number. So what you can multiply together to get that number. So what do you guys think? 5 times?
9.
Good. Also, don't forget about your negatives. Negative 5 times negative 9 also works, right? You give me a positive 45. So you always have to have both versions. And you would go ahead and list out all the factors. So I also have like 45 and 1, and negative 45 and negative 1 as well, right? Now we could have more factors, but I see we've found what we're looking for because you want to find the pair of factors that adds up to whatever this number is right here. And did we find that? Yeah, because the sum of 5 and 9 is 14. The sum of negative 5 and negative 9 is negative 14. This is 46, and this is negative 46. So this is the one I want because it adds up to this term right here.
Wait, how is that negative 46? Don't be negative 45. 45.
No, you're adding them together, not multiplying them. Yep, you have to multiply them together to get to 45, but then you add them together to get this number. It's kind of weird, but that's how you do it. So, everybody understand why I picked the first pair?
Yes.
Okay. So, what you do from here is once you pick your pair, you write it 2 parentheses, you put your variable right here, and then you put in your numbers. In this case, both these numbers are positive, so it's going to be plus 5 and plus 9. And this will be your factored form. So it's from this x right here. So this is just like a method on how you do it. It's not like the other one. These 2 x's are actually represented here and here. So if you were to actually multiply this out, you guys remember FOIL?
Yes.
So if you were to FOIL this out, you would actually end up with this again. So if you want to check your work by FOIL, you can, and make sure you get this as your answer. So we're basically doing FOIL in reverse. Okay, so you're starting with the trinomial, and you're breaking it up into two binomials. And then you can go backwards and get it back into a trinomial by FOILing it. So you're reverse foiling, basically. That's what we just did. So we definitely want to try another example of this. So you guys want to do number 6 together?
Yeah.
Okay, let's look at another example. So I'm looking at number 6. Number 6 is w squared minus 15w plus 26. First thing you always want to check for is there a GCF? And the answer is no. So we can move on to our next step. Next thing you want to make sure is that it's a trinomial in the form ax squared plus bx plus c, is it? Yes, it is. Next thing you want to check, is my a value 1? Yes. So we're ready to move on to the next step. We take this number, whatever its sign is, we take that with it, and we write it over to the side. And we want to find factors of this number that add up to, I thought I was on highlighter, that add up to this number. Now, very important, whatever this number is, whatever these numbers are, you need to take the sign with you, okay? So I want to add it up to a negative 15. So what are some factors of 26?
2 and 13.
Good, 2 and 13, which means that we also have
Negative 2, negative 13.
negative 2 times negative 13 because the product of two negatives is a positive. Now, once you start getting a list, you can add up those two numbers together. In this case, the sum of these two is, and the sum of these two. Good. So we found what we wanted. We wanted a negative 15. That means that this is going to factor into w minus 2, w minus 13. And like I said, you can always FOIL to check your work. We just have not a lot of time today, so I'm not showing that step, but I know you guys all know how to FOIL. But maybe at the end I'll do one. All right.
So after you found the GCF, then would you do this?
Yeah, we'll do one like that, where there is a GCF.
Yeah, I was looking at 12, and I kind of like...
Yeah, so let's do number 11, which is like that.
Okay.
So I'm looking at number 11. So I'm looking at number 11. Number 11 is 2k squared minus 16k minus 40. So in this case, I checked, do I have a GCF? Yeah, what is it?
2k.
Not 2. I mean, not k, but just 2.
Oh, okay, so like if the entire variable doesn't have...
Yeah, they each have to have a variable in order for it to be included in the GCF. Basically, everything has to be divisible by it.
Okay.
Okay? So I divide everything by 2, and when I divide by 2, that's just going to bring my 2 on the outside. And this is going to become k squared minus 18k minus, did I say 18? I wrote it right. 8k, sorry. I don't know why I said 18. Minus 20.
Then would we do that one thing?
So whatever you divide everything by, like whatever your GCF is, you always have to bring that on the outside.
Would it go with the factor when you're done, like the x?
Yes. At the end, it's going to still be sitting on the outside. Yep, your GCF always comes with you, it just stays on the outside. Because at the end, like if you were to actually try to get it back to the original, you would have to FOIL, and then you have to distribute the 2 back out to get back to your original. Okay. So from here, we now want to make sure that we have a trinomial in the form ax squared plus bx plus c. And are we in that form in the parentheses? Yes. And is my a value 1? Now that we did that?
Mm-hmm.
It is 1. So from here, I now take my c term in the parentheses. And this time my c term is negative. So this changes things a little bit. What two numbers give you a negative? What times what? A positive times a negative. That's the only way you get a negative number, right? So in this case, all of my factors have to have a positive, factor pairs have to have a positive and a negative component. So I know that regular 20, for example, 4 times 5 is a factor. In this case, it's negative 4 times 5 is my factor, and negative 5 times 4 is my factor. Because remember, to get a negative number, you need to have a negative and a positive. What are some other factors of 20? Good. So negative 10 times 2 and negative 2 times 10. Now we're going to add up each of these and see what we get. This one gives me 1, negative 1, negative 8, and 8. Which one do we want? Good, we want this one. So how I'm going to write this, you always keep that 2 on the outside. Whatever your GCF was, you just leave it there. And it's just going to become k minus 10, k plus 2. And that would be your factored form.
What did you do for number 8? Because C is 1.
Factors of 1 are 1 and 1, or negative 1 times negative 1.
So you just divide that by 1.
Yes, so in 8, for example, your factors are going to be negative 1 and negative 1, because that adds up to negative 2.
Oh, okay.
Alright, so let's try one that isn't as straightforward. Let's try 14 on the back. So I'm looking at number 14, because we have to do something differently here. So first thing we do is check and see if we have a GCF. Do we have a GCF? No. We don't have a GCF because I can't divide each of these terms by the same thing and get a result. Okay, one of them is going to give me a fraction no matter what I do, except for 1, which isn't going to help us. So in this case, we have a trinomial in the form ax squared plus bx plus c, but we can't factor out anything. So our a term here is not 1. Okay, you guys see how the a term here is not 1. So this requires us to do a slightly different process when this happens. So when your a term is not 1, I'm going to talk you through all the steps. So the first thing you need to do is make sure you factor out a GCF if there is one. There isn't here, so we're good to go. If there is one, you have to make sure you do it before you do this step. From here, you're then going to multiply your a and your c. And when you do that, you're going to be left with x squared plus 5x minus 24. So you multiply these two numbers together and bring it over to where the c is. Yeah, for now it's going to get rid of the 12. So this is like a trick to get rid of the 12 so that you can factor it. And then at the end, you're going to have to do something to balance it back out after you did that.
Why does it just straight get rid of the 12?
It's just a factoring trick. Basically, you're just manipulating it, and then in the end, you're going to counteract it with division. So from here, you now can treat it like the other problems we've been doing. You're going to find factors of negative 24 that add up to what? Good, positive 5. So I'm thinking it's going to be 8 times negative 3. What do you guys think? Yep, that adds up to positive 5. So that means my two factors are x plus 8 and x minus 3. Now we're not done with the problem because we did something weird here. We multiplied everything by 12. So in order to counteract that multiplying by 12, we need to divide to counteract the multiplication. So what you do when you do this is you divide each of these by 12. Now, neither of those numbers are divisible by 12. Sometimes they will be. So what you do is, if they're not, you have two fractions that you need to reduce. Okay, we need to reduce these fractions. So what is the reduced form of 8 over 12? Good, 2 over 3. And then over here, what's the reduced form of 3 over 12? Very good. So what you do to finally complete it is whatever you found your fractions, you take the denominator, bring it in front of the x, and you end up with 3x plus 2 times 4x minus 1. And that is your factored form, and you can confirm that with FOIL if you want to.
Oh wait, so we don't leave it as a fraction?
No, I used to do that in high school. My teacher would get mad at me, so I'm gonna say no. It's technically right mathematically, but it's not the nicest factored form. Do we have any questions on 14? Okay. So the rest of these are similar. Sometimes you're going to have to factor out a GCF and then deal with the problem. So there's a few examples of that. There's times when your factor is going to be really big and you're going to have to find factors of it, and it can be kind of challenging. You guys want to try 16? That one's a little harder. So number 16 is 16m squared.
No, it's 5p squared.
Oh, I'm looking at 18. My bad.
Is 18 the hard one though?
Oh, they're both. All right, we'll just do 16. I just was reading the wrong one. 5p squared plus 22p minus 48. That's the right one. So in this case, do I have a GCF?
No.
No, I don't. So I can't factor anything out. Do I have a trinomial in the form ax squared plus bx plus c? Is my a value 1? No. So we're going to have to use that method where we multiply. That's going to give me p squared plus 22p. Yeah, I think it's
Minus that number.
240. And now we're going to look for factors of negative 240 that add up to 22. So this is the part that can kind of take you some time, because you're going to sit in your calculator and be dividing stuff, trying to figure out what it is. And that's just a little time consuming, and there's really no way around that. So I'm seeing like negative 40 times 6, negative 6 times 40. That doesn't work. Let's try 30. Oh, yay. Do you get it? Good. So yeah, negative 30 times 8, was that what it was? And then negative 8 times 30. So this is the one I want because it adds up to a positive 22. So this becomes p minus 8 times p plus 30. And then in this case, we have to divide everything by 5. So in this one, can I reduce this fraction? No. So what do I do with the 5? Bring it over in front of the p. And over here, can I reduce this fraction? Yeah, it just becomes 6, so you don't have anything to bring over because it would just be a 1. So that would be your final answer.
So if you can't
reduce it, you won't bring the 5.
Correct, yeah, that one completely divides. So if you were to reduce it, it would have become 6 over 1. If you bring a 1 over, it's just 1p plus 6, which is the same thing. Okay, does that make sense?
So if you can't divide the fraction, like negative 8, negative 5, you just bring it?
Yep, if it can't be reduced, bring the denominator over. If it can be reduced, reduce it. And if it fully divides, divide it.
Okay.
Alright, let's try difference of squares. So I'm looking at set 3. So let's just start with something simple like number 1. Well, not number 1, but 21. That's x squared minus 4.
Would you just square the x and square the 4?
No.
Or,
So for this question, what you're going to do is you're going to write 2 sets of parentheses, okay? Now, first thing you always want to check is, do we have a GCF? And the answer is no. So this time, you're not looking for your question to be in the form ax squared plus bx plus c. What you're looking for is, are each of those two numbers on each side, or whatever terms they are, can you take the square root of them? Yeah. You can take the square root of both of those. So this is what we call the difference of squares. So when you see that you can take the square root of the left and the right term, and there is a negative sign between them, that's when we can use this method. So when this happens, we're going to write a negative sign and a positive sign right here in the middle. And you're going to take the square root of both of those two terms. So what's the square root of x squared? Just x. So the x goes here. And what is the square root of 4? 2. So that is your factored form. Now, if you don't believe me, you can FOIL it and you'll see that you get the same thing. The original thing. Now, I do want to show you an alternative method for this, just to kind of help you understand why this works. So, as you know, this is not in the form ax squared plus bx plus c, right? What is it missing to make it not in that form? It's missing the b, right? But I could rewrite it to put a b in there. I could say x squared plus 0x minus 4, right? I can just write the b term as 0, because what is this term actually? What's 0 times x? 0. So I didn't change the integrity of the expression by putting in 0x, but it's going to be a tool for us. So now we have a trinomial in the form ax squared plus bx plus c. My a term is 1. I can use this method by finding the factors of -4 that add up to 0. Factors of -4 that add up to 0 are -2 times 2, right? Those add up to 0. Those are my two factors. So that's just another way of looking at it, what we did. So you can always do it that way too. Sure. Let's do number 26. Okay, hang on. Everybody good on 21 before I move the page? Okay, let's look at 26. So for number 26, I have 2a squared b minus 32 a to the 4th b. So first I'm looking for a GCF, and I definitely have one this time. What is it? 2 is my numerical GCF. What are my variable GCFs? Good, a squared b, very good. So I'm going to divide everything by that by factoring that out, and that leaves me with 2a squared b times, this becomes just 1, anything over itself is just 1, minus 16a squared, because the b's cancel. Now, if I were just learning this, I would have thought this question was done. Alright, the first thing you see, you're probably thinking we're done factoring, but we're actually not done factoring. Right here, this is actually the difference of two squares. Because can you take the square root of 1? Can you take the square root of 16a squared? Yes. So we can rewrite it as 2a squared b. Remember, when you take the difference of squares, you have a negative and a positive. You take the square root of 1, which is, what's the square root of 16? What's the square root of a squared? A. So a tip is when you're taking the square root of a variable, it has to be to an even power, and then you just divide that power by 2, and that would be the square root of it. Has to be an even power to take a square root of it. And that would be your final answer. I think that's the main thing I wanted to talk about. Is there any other one that you guys want to look at in difference of squares before we take a break? I'm sorry, what did you say? 24, sure. Alright, number 24. So number 24 is m squared n squared minus 49. So I can't factor out any GCF because I don't have one, but I have the difference of two terms that I can take the square root of. So I rewrite it as plus minus minus plus, and I'm going to take the square root of this term and the square root of this term. So when you take the square root of variables, if those variables are to an even power, you just divide the powers by 2. So what is the m squared going to become? And the n squared? Yep. mn, and then what is the square root of 49? 7, and that would be your final answer. And like I said, with factoring, you can always check your work by foiling or distributing your answer back out to ensure that you have the right answer. So our timing's pretty good. I'm going to give you guys a 10-minute break right now, actually a 9-minute break technically, because we have to start at a certain time. So I'll give you guys a 9-minute break and then we'll start the next lesson.